All right, welcome back, everybody. Sustainable engineering. This is week 10. And nice job, those of you that uploaded the life cycle assessment project. Good job on that. It's typically a pretty in-depth process, so a couple of them were a little thin, but that's okay. First run at it, right? Today, I want to talk about a software called Revit, and we have this software here at the college. Typically, if this is a face-to-face class, we run a Revit. We do 1 or 2 weeks of Revit. And Revit is an AutoCAD or an Autodesk product, kind of like AutoCAD is. It is an architectural engineering software that allows you to build structures three-dimensionally and also give those structures regular material properties. So if it's a wood structure with, R19 insulation in the walls and R30 insulation in the floor and R60 insulation in the ceiling, excuse me, you can give it all those properties. And then you can place that structure in a location like Gresham, Oregon, or Prineville, Oregon, or wherever you want, and a certain time of the year, and you can run an energy model on the structure. So it's very cool, especially for sustainability purposes, because it allows us to understand how different materials transfer heat or keep heat out of a structure, and also what we can do to enhance those. So they did not load the software because I didn't ask for it because I knew we weren't face-to-face, but then I wanted to kind of demonstrate it to you and I couldn't. So I found a video that's a pretty nice tutorial, and I'll put the link up in Blackboard so you can watch it in its entirety if you want, but I'm going to run it and also pause it and talk about what he's doing because he goes pretty fast. So you can at least get your eyes on the software and what it does. And then at some point, if you wanted to play with it here at the college, you could do that because we have the software. I am going to get it loaded in the lab and also on my instructor station because I like to use it in other classes like capstone at the end of the year, potentially. That's a great capstone project, is to work with Revit and learn that software deeper. So let's look at what I have loaded up. So this is the gentleman, his name is Vulcan. And this is the structure he's going to work with. So when we first run Revit, we work with pretty simple structures, but he goes through and talks about the characteristics of Revit. So I am going to try to enlarge it. I'm going to make myself a little smaller and see if we can run it. This little lower bar is bugging me, but there we go.
As you can see, I have a model, and by the way, this is the model that's available on those advanced courses. I have a 5-hour course where I show you how to build this house with all of the project documentation that go along with it. But anyways, this is the house that I'm going to be using for this tutorial. So here, before we can get into the energy model and energy analysis, first let's look at some of the building elements and what do they have to on offer as far as all of the performance settings or energy performance settings. So let's take a look at here at the exterior wall. So this is a basic exterior wall, 37 centimeter is the thickness. And if I go here into edit type, here we can see some of the properties. And here, if I scroll down, here we have some analytical.
So he's going very fast, but essentially you can click on a wall and see what the properties are and see what they're set to. Now, what the actual properties are is probably less important than the thermal characteristics of the wall. So you can see he's got heat transfer coefficient in here. There's thermal resistance, that's R, thermal resistance in here, and thermal mass in here. So that can get pulled from different materials that you choose.
Properties, and we have the thermal resistance. That's the important number, the R, and here this is that number.
Oregon State residents, if you have a utility meter like this on the side of your
Sorry.
And so basically this number, as you can see, it's grayed out. So it's basically calculated through materials. So we have to go here into structure. And now here we have all of the materials. So if we go maybe here into our thermal layer. Let's open that up. We have this polyurethane foam material, and all of these materials, when you go here on the thermal tab, you have all of those options. And actually here you can change some of these properties. As you can see, you can click and then edit those if you want. I suggest you don't do this unless you have specific information from the manufacturer. If not, I suggest you just leave these as is and then use default materials that come with Revit. If you have information from your material supplier or material manufacturer, then input that information here for a more accurate model. Okay, so that covers walls. Basically, it's the same thing with roofs. If I select one of the one of the roofs, we have a basic sloped roof, and here we have that same thermal resistance R. This is the number, and again, that's calculated by here again with.
Here you can see the layer up, like there's asphalt shingle, there's damp proofing, there's plywood sheeting. All of those add up to the total R value of your roof. So unfortunately, this is in the metric system, so the numbers are not as common. If you are used to the numbers, they're not as common. Like our values are something like 30, 40, 60 type of thing. And these are a little different because they're in the metric system. So
we have the same thing. We have that same polyurethane foam, and here we have the same thermal info. Also, not only that, but even like plywood sheeting has some sort of thermal properties. So basically, Revit is adding all of those layers up and giving you that that final number here. If I just cancel out of this, that final number here as analytical properties underneath thermal resistance. Okay, so that covers walls and roofs, which is pretty much all of the building elements. We also have floors. Same story, just calculating all of the layers included. But we also have some openings on our building. So, for example, this building has these windows, these aluminum windows. Now, if I go here into Edit Type, underneath analytical properties, now we don't really have any information here. The reason for that is I made this family for this project, and I didn't really input any analytical information. But for our analysis, we do need that information. So I'm just going to go here under analytical construction, open that menu up, and basically here you can put in what type of glazing or what type of
so these are all different types of windows that you can choose in Revit. So you can use your exact windows that you have in your structure or that you're going to order for your structure, and it'll bring in the R values. So you'll see that there's a lot of heat loss through windows. So as you change the window structure, you can run these energy models and see, what the efficiencies are. Like, would it be worth your money to buy higher level R value windows? And what would the payback be, right? If you're going to save $50 a month in your heating bill and the window costs $300, then you can kind of figure out like, oh, 6 months, 6 months, that's a payback. So then within a year, you're saving money based on a better window choice. So
a glass window this is. So here, for example, I can go for like double glazing, 1/4 inch thick, blue, green, low, whatever. So you basically search for something that's closest to whatever your manufacturer is claiming for their window, and then you input that information here under analytical construction. And of course, hit apply. Okay, and we have to do that for all of the windows. So here I have this small window, so I can do the same thing here. Let's go with the same one for each one. Now, of course, this isn't a real building, so I don't really care that much about what I'm selecting here. But again, as I said, if you're doing this on an actual house, make sure you have correct manufacturer information. Okay, but we don't only have windows for openings, we also have doors. So here I have this door. This is the one that comes with Revit, I think. Yeah, and here, if I scroll down underneath analytical properties, here the construction, as you can see, analytical construction is wooden, so Revit is just taking in that information. Of course, you can set it to something different, like wood frame glass and something like that. let's just leave it at wooden. The same thing here, we have a garage door. And if I go here into edit, I can go to analog properties, and now construction is metal, just because it's a metal garage door, of course. Let's cancel out of that, and I think I have a few doors here. So let's select this one, and yeah, it's wood with glass, because as you can see, that's a door that has both wood and some glass on it. Okay, so that's as far as all of the openings are concerned. Now, that's basically where you input all of your information as far as your model is concerned. One more thing that's really important as far as energy analysis is the location of your building, just due to just due to climate, because climate is really important.
So as I said earlier, this is where you're going to choose like where this thing's located, what time of year it is, and all the parameters for running an energy model. So you could do it wintertime for like heating and heat loss, or you could do summertime for like cooling and cooling loss. So
Or energy analysis. So to set that up, we need to go here to the Analyze tab. And here on the Analyze tab, we have our project location. And we just need to open that up, and here, let's Revit find it. Okay, so currently it's set to Boston. That's by default. I'm going to leave it as is, but here we have some weather stations. And you can just select one of the weather stations and hit OK, just because Revit is going to be using that weather station to get basically weather information for your location, which Revit is going to be using to perform all of the analysis. Okay, so once our location has been set, we need to do some energy settings. So I suggest you go here to your energy settings dialog. Now here for model, you can do this for your building model, like the one that we're using here, but you can also do this with your just a simple mass. So if you only have if you only have mass, in place massing, or something like that for your building, you can use that. So then in that case, you would go with conceptual mass, or with conceptual mass with building elements. Because we only have building elements here, I'm going to use that. And if you want to
so building elements are walls, windows, doors, floors, ceilings. So it's all of those components that he talked about in the beginning that you set your properties to. So
maybe a tutorial where I talk about massing and using conceptual masses for analysis, leave me a comment down below and I'll make that tutorial. Okay, anyways, let's go here with building elements. The ground plane, we have to set that. I think I'm just going to leave it as is. The project phase is new construction, analytical space. Now here, this is really important. Now here, analytical space, before we go any further, let's talk about spaces and rooms. Now for this project, I actually had to make this floor plan room diagram. And basically here, as you can see, we have all of the rooms. Now here I have one room that's just an outside area, and we can't have a room as an outside area, not for analytical purposes. So I will have to select that and delete that room. Okay, so we have a lot of these.
So from the floor plan, you can designate what you're going to run the energy model on. For example, I would not choose the garage because typically garages are not heated, but you would choose all of the rooms and the living room like he has chosen right now. So when you're in Analyze, you actually just mouse over an area and the X shows up, that blue X. And then you click it, that becomes part of the energy model. So if you wanted to not include like the entrance, maybe you want to not include that. The garage not include, right? So you can choose the areas that you want to run the energy analysis on.
Now, before we can use these rooms for our analysis, what we need to do is just make sure we change some settings for rooms. So go here to architecture, goes to room and area, open that menu up, and let's go with area and volume computations, and then change it from area only to areas and volumes. Okay, because for our energy analysis, we actually have to have room volumes, not only areas. Moving on, let's go here into one of the sections to view those rooms. Now here in this section, you can't really see rooms. That's why. That's because by default, Revit basically shows rooms only in floor plan views. So in this case, we need to ask Revit to show us rooms in a section view. So we do that just by changing our VG or visibility graphics override. So what you need to do is just go here to visibility graphics in the properties panel, open that up. So here we have that visibility graphics overrides panel, and just scroll to rooms.
This is if you want to define rooms from a section, which I don't ever do. So I just use floor plans. So I'm not sure what the advantage to this is, but he's showing you anyway.
Okay, rooms, here we go. Open up the drop menu, and here we have our basically color fill, but let's open up rooms here completely. Hit OK, and there we go. We have our rooms, and as you can see now, they are covering pretty much the whole height of the room. Now here in this case, it's not covering everything, so you might want to like expand it just a little bit so it goes all the way here up to the corner. Okay, so once we have all of these rooms set up with both.
Okay, clearly that was the reason right there. If you had a room with a vault, which I don't typically do, you have to drag that room all the way up to get all of the ceilings. So that's why he did it in the section view.
Areas and volumes, we can go back to our, let's go back to our 3D view.
What could you do with the Metal 3D printer?
These commercials, what a pain.
Introducing Metal X, the easiest way for you to go from design.
That is a cool
We
commercial.
go back to our analysis tab. Sorry, I have a bit of problems with some allergies, so my voice is a bit off today. But anyways, let's go here and let's go back to energy settings. So here I'm going to go to, and now we have more information here just because we have all of those volumes. Now let's go here to other options, and here percentage glazing, well, we don't really need that, but what we do need is building type. It's not an office, it's a single family home. So let's.
So this dialog box is where you put in information about the building, right? That's going to help Revit understand the use of the building and create a better energy model. So
like that, building operation schedule, well, it's going to be with people 24/7, so let's add that. And here we have the HVAC system. Now I'm just going to leave it as is. If you have more information on the on your HVAC system that you're going to be using,
the one that's the most common that we use is a heat pump, because heat pumps are very popular in our region right now. So this is a central VAV with heat, right? And a chiller. So it's like a heat pump. It's not far from a heat pump. So you can, this is not a bad choice for our region.
Or for your heating, ventilation, and air conditioning system. That's what HVAC stands for. And then I suggest you input that information over here. And yeah, that's pretty much everything that we need. So I'm just going to hit OK, OK again. Now what we need to do is go here and create an energy model. Now when you hit create energy model, you're going to get this dialog. You just go and create an energy model, and that energy model looks like this, and it's loaded in, as you can see over here, as a new analytical space 3D view. It looks something like this, and you have all of your rooms. So if you select one of the rooms, here it says, okay, your area, your volume, your occupancy load, lighting load, power load, all of that. But this is only half of the process. So now you have all of this information here, but you actually want to get further information and to do all of the other analysis in the cloud. So for that, you have to go here to generate, and basically you're generating your energy optimization analytical model, and you're just uploading that to cloud. So here you would use existing if you're using the existing file, so you can just go with that. And here you just say, okay. And basically it uploads your model to cloud, and then it will email you once it's finished, and then you can open it up by going here to optimize. So you click optimize and it opens it up in your web browser. Now I already have that opened up, and let's go back a page. Okay, this is what that will look like. So as you can see, this is the one that I've just uploaded, but this is the previous one I had done when I was just testing these things out. So it appears just like this. It will open up this Autodesk Insight website where you can download all the information. And if you want to download information, just go here to export and then you download it, or you can click here and just open that up. Now here it gives you your use and how much it's going to cost per year to basically heat up this space. And as you can see, this is the analytical model. You can actually kind of go around in 3D, but the more important stuff is down below. So if I scroll down here, you have all of the tips and tricks and how to improve your building for optimized energy or for energy optimization. And you can scroll down here and you can get more information on any of these. So as you can see here, you get window shades, stuff like that. And here we have some information on this. Now this is really nice, but you have to open it manually. So what I did, if I just minimize all of this here, I've downloaded that energy model, and that comes as a kind of compressed file like this. So I've just exported as this model, and basically this folder is everything you get. So you basically get these images. So I can just go through these images, and this is your complete energy model, and you can show this to your client, to your professor, or just use it yourself to make it.
So I went through that really quick, but there's some really interesting data in there, and you get data on all parts of the home. So, you know, your windows, you can get data and cost on that, your walls, your ceiling, your floor, all of those things you get independent data on. It's really fascinating, and payback data. So he went through that really quick, but I wish he'd gone slower because there's spots where you can see these different charts. So back here, there's a payback, a PV payback. So yeah, it's really super fun to work with. I'm sorry that we're not going to get to do it, but I definitely wanted to show it to you and know that this is how a lot of big buildings are being modeled, commercial buildings. And this information is both given to the engineers and the owners of the building, so they can make decisions on material finishes, wall construction style, all of these different things, and payback. Really, really fascinating stuff. All right, let's see how he gives us another view of this.
And you can show this to your client, to your professor, or just use it yourself to make improvements to your model and better design decisions. So that's everything you need to know about energy analysis.
Yeah, that's all he's going to do. So that's it. I hope you enjoyed it. I hope you like it. And I will get it in the lab, and we will find other opportunities in person to run it. I'm going to put up just a couple questions on Revit in the submission area. So make sure you go and fill that in. I'll do one more lecture this week, and then we'll have our final on Monday. So you can do that online anytime Monday, but it's got to be done Monday. I will, in the next lecture, talk about the final and what will be on it. So, all right, have a good day.